How to build smart information systems, actually, mainly, is the main question. The smartness, and here is the autonomous activity or the capability of the information systems for making decisions or for taking decisions or for generating decisions. So the smartness here is to help automate the behavior within the information systems. When the question says on the available technologies, so the technologies actually is the used technologies, infrastructure, whatever. It is not the main concern. Smart information systems means information systems with an autonomous capability to take decisions, to decide what to start, what not to start, what to do, what not to do, and so on. Stop answering the question for us. I'm answering. Stop answering the question and focus with me, please. That's how to build smart information systems, is just to guarantee the autonomous aspect of the information system. Then we guarantee the intelligence and the capabilities of an information system to deal with the up-to-date technologies to take the most appropriate decisions. Full stop. Okay, let's get terminated with what we started. Actually, the information technology emergence and emergency within the infrastructure, within the environment. We stopped at the level of generating web services. We said that they are a sort of interoperable. They are tools that they have actually components over the web, or services over the web, or functions over the web, or applications over the web, interoperate. We're giving the example of a web application communicating with a mobile game. How they would communicate. The question is imposed here. Why? Because the web application is implemented with a complete standalone environment, and the game application is completely a different platform. So how we will make them communicate? Using a web service. Using a web service. So the web service will generate a relay to help heterogeneous applications communicate. Even the homogeneous, they would succeed in communicating using web services. One of the very famous utilities to create web services is the XML, the extended or extensible markup language, is an HTML-like programming language, so web-based mainly, and it is utilized to generate services such as the web services. Still in the trends and let's say utilities, enhancing the information technology emergence and emerging technologies, whatever. The service-oriented architecture, the SOA, is one of the architectures that help communicate the service with themselves. Means if they need something, they would actually find a solution somehow. So self-contained services that communicate with one another to create a working software application. Yes. Other combination actually is seen to make actually governance and assemble other applications as needed, whenever needed, and upon the request. Yes, we can refer to the case study that we have of the dollar rent-a-car, and here the dollar rent-a-car is a system that you can see it here. Actually, is this blue here. Let me try to maximize the view. Yeah, this blue here is the main service of this dollar rent-a-car. This is a case study, and it is this dollar rent-a-car actually it is gathering numerous functionalities upon the need mainly here. Yeah, we can see the operating system. We can see actually the web interface. We can see actually the business features. The business features that they actually present, and the partners, or let's say the stakeholders in the environment, or things like that. And this system here is hosted on a server. This server actually is having its policies and politics to run. So it is compiled to generate the $car system. So this is just a graph to demonstrate the interoperation between the components of a system that tries to make, let's say, to deliver a service. And this is a service-oriented architecture. Means here this is a service, this is a service, this is a service, this is a service, and so on. Okay, software outsourcing is one of the features of nowadays technology. Means if we can define the cloud computing, still here we can see the same features available here when we nominate the software outsourcing. It is a context via which we can see providers provide the functionality of implementing or developing a software based on a contract. Means a firm, let's say University of Newsbury, is needing a software for, let's say, making registration of students. It might ask from a developing company to develop this software, and this is said a software outsourcer. So they are requesting an outsource, yes, a freelancer or a company, dedicated company, to do so for them based on a contract. The cloud-based software is another solution. The cloud-based software is another solution. Here, the software as a service, the SaaS. We saw that, we defined that. This software-based software as a service is a software to be utilized for the same target, but it is available on the cloud. It's not available on local. So the company will use over a computer network, which is defined as a cloud network, and it is paid service. Mainly, it would be a paid service, not only, but it might be free also. It depends on the software itself. But this is a third-party delivered application. The company will use as per its need only. Software outsourcing. Yeah. So actually, upon the years here, if you can see, upon the years, the use of the software and the outsourcing of software is increasing, and this increase in software outsourcing, it decreases the money spent on the software implementation, and at the same time, it is once the expenses are decreased, the gains are increased. So you have to see it this way. Okay. Still in the same context, actually, in the context of the software outsourcing and the services over the cloud, we can define a kind of utilities, I may say, software. They are software applications. They are made up of more than one solution, and they are more than one, at least two and above. And those two solutions, they are delivering one service at the end. We can take the example of the Google Maps. We can take the example of the Google Maps. Actually, it is a very good example when we see that these Google Maps, it uses the GPS from the mobile device, if we are using a mobile device, in addition to the software, which is web-based software from the Google, to localize the user and to show the map where the user is, the graphical view. So this is a mashup view. This is a mashup view. This is actually it's a scenario via which we can see the outsourcing, because the Google Map is the map only, but the device and the local content is not the Google related content. It is related to the mobile or to the technology, the GPS. It is a hardware, so it is an outsourcing. But here, because of the Combination, we are talking about a mashup. Because of the combination, we are talking about a mashup. Also outsourcing, we may talk about software applications that they actually provided services, different kinds of services, and those services they are dedicated to either to be genuine or let's say licensed or free or open source or whatever, but in all cases they are delivering services. And those apps they actually need to be utilized upon download or upon request or upon access. We may give the example of the mobile applications that they can be downloaded over a store, which you can use to search for different and a variety of service delivery applications, whatever. It is a matter of understanding here. And here, actually, this context, let me come back. This context of apps, it ties you as a user. It ties you as a user to a specific platform. Because if you have, if I give you the example, let's take the example of the Favabay I given you in the assignment. You are tied to the Google only, so you have to download the application from the Google Play only. Otherwise, you do not have the chance to use it. So the application is tying you to the specific platform. Yeah, the resiliency and the platform growth is one of the considerations for both the information technology and the information systems. It means the organization of the service delivery or service owner has to consider such a criterion. The market growth, consumers growth, production growth, all in a context of trying to make the infrastructure flexible and can be expanded and extended also. At the same time, actually, it can be delivering more and more, increase the production to a bigger size or to bigger numbers to fulfill the requests. So here we talk about the market change or the infrastructure change, platform change even. Governance here, it is a context. Actually, we talked about the governance and the flattened aspect of an organization whenever we talk about the digitalization, but still the governance is one of the concerns, even with a purely digital environment. There have to be actually a governance scenario. The governance can be seen in a centralized mode or in a decentralized mode. When we talk about the decentralized mode, we talk about a focal point that can make decisions and can discuss the decisions and can distribute decisions. Centralized, a department for that only, or just a point for that, or a head for that. Decentralized means there are so many parties interfering to build up a decision. Departments with the segregated geographically, or they are from different disciplines or something like that. They all have to act to generate a decision. So decentralized. Here the consideration of this governance, you may say that let's go with this centralized since it's much more easier and much more effective. Yeah, it depends on this. Do you really have the intellectual capability to make decisions or no? If yes, that's it. Otherwise, you have to go for the decentralized as a business owner. And once you go for this or the other, the costs allocated for this architecture or the other, it has to be considered. The TCO, the total cost of ownership, is actually is a scenario, is an architecture, it's a behavior via which we can see the effectiveness of being the administrator, being the manager, being the owner of a product or of a service. Means You are delivering a service, and you need to have the software that runs the service in your local environment. So, okay, what is the cost? The same scenario, you are willing to deliver a service, and you are willing to make the software generating the service on the cloud, not in local. The same way, what is the cost? Which one actually is much more fulfilling you? So this is what we can call it the total cost of ownership. And the control of this cost here actually can be controlled in the sense of it depends on what is the service itself and the availability of the running utilities in background, the responsible parties to generate the service or to finalize the service or something like that. Okay, the final part here in this unit, talking about information technology infrastructure and the emerging technologies also, is the 7 forces that they actually draw in the model of the IT infrastructure. When investing in infrastructure mainly. The demand for the service given by the company, the strategy or the strategic view of the company, the cost, effectiveness, prices, budget, the technology viability and reliability. Is it really satisfying to use the technology available within the firm's hands, the technology? The service, are they up to date and really competent and competitive when we put it into the market? Are they actually at the level to compete in the market, the services? And at the end, actually, the investment here, the infrastructure, let's say the IT investment, no more or less, by the company. They are drawn here to us. They are drawn here to us. Here and those forces, those points. They are going to draw the force to draw the model of the infrastructure, the IT infrastructure that the company has to go for. Any questions, please, at this level?
No, Doctor.
That's great. So let's pass to the unit number 6, which is the business intelligence. And here we are going to use the backend technologies to enhance the capabilities of information systems to be autonomous and to be able to generate decisions. We go to databases and we see the definition of what is a database and what are the kinds of databases and how to use databases, things like that. So we are in the context of business intelligence. So what we are going to see in this unit is the work with the backend technologies to help information systems make decisions, build decisions, generate decisions, be accurate, be punctual, and so on. We'll define the technologies behind, which are mainly based on the use of the DBMS or the databases, DBs, or the DBMS database management systems, the engines running the databases. Okay. This is a case study that I want you to read. This is a case study, which is the Toronto Globe and Mail system that I want you to read, please. Another actually part or portion from this same system, just please read it, the subsystem, sub mechanism, actually, it's an organization, this one. Okay. What we can start with here to define, to reach the definition of what is business intelligence, the habitual and the architectural, sorry, not the architectural, the historical view of all companies, it is to use paper-based services and to generate services over papers, and the bureaucratic view of companies, they are dealing with paper-based activities. Thus, this is a traditional view of the company. Okay, the first definition of what is a database and what is a data store, what is actually bureaucratic record, something like that, through which we are going to let's define those terminologies, and we'll define the database. Then we'll define where we can find this database within the business intelligence. A database is a context of related medias. Here it is said files, but it's not mainly to be files only. We can say media in general, in abstract, because databases, they are data stores to store media. The media can be file, can be media itself, text, audio, video, images, and so on. All. A file or a resource, it's in the database, inside the database. It's a sort of group of records. I can say the student profile is a record. The college profile is a record. So it has the name, the ID, the number, the date, whatever, the contact, and so on. It's a full record related to the same type. It's a record, but a secret here that has to be related to the same type. The record is related fields. Yeah, the ID, the name, the whatever the problem, the contact, the subject, the major, the department. All of those, they are fields in plural. A field is a value. Is a value. Might be number, character, varchar, combination of alphanumeric. It's a value. It's a value. The context of the field, it is presented as an attribute, which is actually having a data type, and this attribute describes actually the object in question, the entity in question, which is the file, the original file, and this attribute or this field or this field, it has a data type. So when you say an ID is a number. When you say name is a character or a string or a varchar, something like that. So it has a data type. The graphical view of the here the representation of the data within a company. When we talk about the digitalization here, we start from the thing that the computer understands, the zero, until what we humans can understand, the files and the resources. So here it starts with a bit, and it goes up to the resources, the resources themselves. A bit is an element of a byte. The bit is the smallest unit inside the computer. The byte is 8 bits. 8 bits is a byte. It's a character. Let's represent it as a character, A, B, C, D, and so on. A field actually is a combination of bytes. Means here a field may be the ID, maybe the name, maybe the department, maybe the major field. We define. A record is a list of fields related to the same type. Student profile, course profile, hospital, let's say profile, something like that. A record. A file is a group of records, the lists of students, all students is a file. All courses is a file. All departments in the college is a file, and so on. The file here is an entity, is a table. Here it is an example, the one. Inside the database or the data store. The group of files, the group of files, the group of resources, the group of tables is the database. Is the database. The database is a list of resources, but they are files actually. Yeah, to hold data because they have to be actually related to the same type. So here the personal data, here the course data, here the financial data. So they are separate. Many tables. Yeah, every table has a concern of one type of data. Why we are talking about business intelligence, why we are talking about databases, why we're talking about digitalization here, and we are moving from the traditional work into the smart environment here, actually because of the issues the bureaucratic activities has shown up to today. If I ask you the question, how many students we have registered from 2004 up to today in University of Nisbet, our campus? There are thousands and thousands and thousands of students. Okay, if I ask you students, I give you a task of just making an analysis manually and trying to extract how many students are named Muhammad from all those students. Will we succeed? Maybe yes. You're not guaranteed because the thousands is huge and enormous number of students. You as a human being might fail, and might succeed. So this capability and this probability here causes issues. I'm giving you just the example to make you feel the hardness of the activity. So the traditional work might fail because it's manual. The traditional work might make works be redundant. A work you did it yesterday, you redo it today. You redo it next week, and so on. Redundant, not accurate, non-consistent. It does not lead you to an end. It is just a small analysis, and it does not have any sense. These the problem. Those are examples of problems that traditional work presents. The traditional work means based on the paperwork, and the very common issue is that if a paper is lost, a full work is lost. There is no security at all. There is no security at all with the traditional work. Yeah, here actually you can the traditional processing. Here you can see from the user's request up to move here up to the storage or something like that. Okay, database. What is the definition of a database? The first definition here to give the database is a data store, the smallest data store to store data. Yet it is given us a centralized data store. What does it mean? All the data they are centralized in just one point. Here, if I come back, let me come here. Yes, the database here. It is one location only, having many files, many resources. They are from different types. This is the cost, this is the person, this is the finance, but all of them, they are in the same location, centralized or centralized database. Database management system is the engine where we can have more databases, one or more databases. So we can use the database management system, the DBMS, to create a database or list of databases. And using those digital databases that they are generated within with the database management systems, all the issues faced by faced within the traditional system would be actually controlled, and they can be eliminated, and they can be actually controlled and put into a frame in order to avoid them easily also. So here we can see, here's another case study actually whatever. Using the same entity, we can generate more than one activity at the same time. We have only one unique entity here. So we have a database that has some attributes, an interface to access this database, and this interface can give the user number one whatever he's asking for, and user number two whatever he's asking for. That so we can do and coordinate works without any redundancy, without any problem, without any making duplication, without losing data, without modification. And if there is any modification, everybody will know, will be acknowledged, and so on. So this is one of the benefits and the main benefits of centralizing the work using digital data stores, which are the databases. I'll stop at this level. I'll give you the link and I'll take the attendance also.